So after which, Marilyn, do not write on my board. It's my board. After which, the acceleration is reduced to 5 meters per second squared for the next 20 seconds. The body maintains the speed attained for 60 seconds, after which it is brought to rest in 20 seconds. Draw the velocity time graph of the motion using the information given above. A. Using the graph, calculate the maximum speed attained during the motion. II. The average retardation as the body is being brought to rest. III. The total distance traveled during the first 50 seconds. And then IV, the average speed during the time during the same interval as in III. Okay, so let's look at how the question, you see, from what you sent, there was a misrepresentation of where the acceleration is reduced to 5. We are told that, please, can you hear me?
Yes.
Okay. The body starts from rest, meaning the initial velocity is 0. So U is 0. And it's given an initial uniform acceleration of 8.0 meters per second squared. So A1 is 8.0 meters per second squared. Okay, for 30 seconds, for a time period of 30 seconds. After which the acceleration is reduced to, so in the second part of the journey, the body reduced the acceleration to 5.0 meters per second squared, and it took for the next 20 seconds, so T2 is 20 seconds. The body then maintains the speed attained for 30 seconds. So we don't know V2. We must determine V2. If we determine V2, then U3 will be equal to whatever will be equal to V2. And the final velocity during the third part of the motion is equal to 0, is brought to rest. But for 20 seconds, so T3 equals 20 seconds. All right, so we have to draw the velocity time graph for the motion. Now, you see, in our last meeting, if we have a velocity time graph, I told you that if you have a velocity time graph, and the graph is like this. Let's assume the graph is like this. This is A. This is B. Without values, if I ask you to compare the acceleration of A and B, which one is greater, which one is less? Without values, if I ask you to compare the acceleration of A and B, compare acceleration of A and B, which one is greater, which one is less, class? Kingsley.
Please, A is greater and B is less.
Why do you say so? Why do you think A is greater, acceleration of A is greater than that of B?
No.
And that is what Kingsley said. Kingsley is saying the acceleration of A is greater than the acceleration of B. If you have a different opinion, share with us. Please, if you have a different opinion, share with us. All right. So on a velocity time graph, the acceleration is determined by the slope. So on a velocity time graph, acceleration is equal to the slope of the graph. Now, looking at the slope, this is steepy or slopey. And slope has to do with the inclined plane. If you look at this, if I ask you to climb A, it will be difficult than climbing B because A is steepy or slopey than B. So when they are starting from the same point, it's true the acceleration of A will be greater than the acceleration of B. Is that okay? Now, if it is a continuous journey, and I ask that in the first part of the motion, the acceleration is greater than the acceleration during the second part of the journey, how would you draw it? So if this is the acceleration during the first part of the journey, and it's a continuous journey, and the second journey's acceleration is less than the first, it must be, because it's a continuous journey, it must be placed, B must be placed on it like this. Okay, to indicate that the acceleration of this is slopey, this one is slopey than this one. Please, are you following? Class, are you following? Giovanni.
Yeah, please, can you repeat it? I didn't get it.
You see, so let me quickly connect it to the question. In the question, the acceleration during the first part is 8.0 meter per second squared. And the acceleration during the second part of the journey is reduced to 5, meaning acceleration during the first part of the motion is greater than, so 8 meter per second squared. This is greater than 5 meter per second squared. Though the acceleration is reduced, but please, it is not a deceleration. A deceleration means the body is reducing speed and seems to be returning to where it started from. So if the motion is here, if the motion started from this point and the body is decelerating, you must see it's the graph pointing to the initial point. This is at this point, V is 0. So you must see the graph returning to the time axis. That is a deceleration. But here, the acceleration is just reduced. Okay, if it is reduced, then the slope of A must be greater than the slope of B during the second part. It does not mean because the acceleration is reduced, it's a deceleration. I'm saying this because I saw most of you plotting this graph as this. When the acceleration was 8, the graph was like this. And when the acceleration was reduced to 5, the graph looks like this. Then the velocity was maintained for a while, so it came to a stop. Please, are you with me? this is the part I'm talking about. If the velocity is reduced during the second part of the journey, it does not mean the body is decelerating. But what it means is that, assuming during the time 30 seconds, the body was moving with velocity of 10 meters per second, 10 meters per second every second. So velocity time. Okay, so this is 20 meters per second, 2. This is 30 meters per second during the third half. Okay, when the acceleration is reduced, what it means is that instead of moving 10 meters per second every second, maybe I want to move by 8. So 8 meters per second, 1, 16, 2, 24 during the third. Okay, please, are you with me? Class, are you with me?
Yes, sir.
Yes, sir.
So this is basically what it means. The body is reducing the speed, okay, within every second. It does not mean it is, okay, so it's like moving from Accra to Cape Coast, but you were speeding. You were going 10 meters per second every 1 second, but you decided that, no, let me reduce my speed to 8. You are still moving from Accra to Cape Coast, but you felt that your speed is too much. Instead of moving at that, let me reduce it. In deceleration, it means that you have attained a maximum speed and you are reducing the speed back to, and then your direction is towards your initial point. But this is not the case. Okay, so let's solve the question and then see how the graph must be drawn. Any question? So let me clear this part of the motion so we can quickly. When I saw the graph alone turned me off. So, this one, if I should mark, almost everything will be wrong. So let me wait and discuss on Tuesday, knowing also very well that I wasn't in a very good state of health. So it's an exposure. The questions are actually to expose you, right? So that when you face similar questions, you can easily be able to apply. Let me check the messages. Okay. Hi, young lady. Yeah, so during the first part of the motion, we are told that the body starts from rest, so and accelerates by this rate within this time. So let's calculate the final velocity. So the final velocity would be equal to u plus at, which is u is 0 plus 8 times 30. And so the body accelerates to a final velocity 240. Then during the second part of the motion, the body reduced speed. The body reduced speed by this. Okay, so the final velocity, because it's a continuous journey, because this is Imelda.
Sebi, is that the solution for I?
No, we are solving everything and then we use it for the graph. Okay, then we go to the next question. Because this is a continuous Benjamin, mute yourself. Benjamin, please, when you join, mute yourself in order not to distract us, okay? Because this is a continuous journey, the final velocity of the first part is equal to the initial velocity of the second part. So U2 is equal to V1. Because this is a continuous journey, okay, the final velocity during the first part of the motion becomes the initial velocity during the second part. So V2 would be equal to U2 plus AT2. And what is U2? U2 is equal to V1. So 240 plus 5 meter per second squared times 20 seconds. And this is giving us 240 plus 100. That is 340 meter per second. So this becomes V2 when the acceleration is reduced to 5 meter per second squared. Please, any question here? Any question here? All right. Then during the third part of the motion, we are told that the velocity is maintained. It's maintained, meaning, oh, Eldad, do not write on my board. If velocity is maintained, then U3 is equal to V3. And they will all be, sorry, U3 is equal to V3, and they are all equal to V2, which is 340. Okay. 340. And during the final part, we are told that the body decelerates uniformly. So the final velocity is equal to 0. So when V is equal to 0, U is equal to 340 within a time interval of 20 seconds. So let's sketch the velocity time graph. Vertical axis, horizontal axis, this is the velocity V, this is the time X. What are the velocities? The body starts from rest, so initial velocity 0. Then we had a velocity of 240. Then we also got a velocity of 340. Our initial time is 30 seconds. So 30 seconds here. Then the next time is 20. So 30 plus 20, 50. Then what is the time to when the velocity is maintained? What is the time to when the velocity is maintained?
60 seconds.
Okay, 60. All right. The body maintains the speed attained for 60 seconds. Okay, so 60 plus 50, 110, 110. Then finally decelerate to rest within another 20 seconds. So within 20 seconds, so this is 130. Okay. So the body accelerates at this rate, and then the final velocity is 240. Let's draw this. So from 10, the body accelerates from 30 and then go to a velocity of final velocity 240. So this graph must look like this. Then during the next part, the body reduces the acceleration, and the final acceleration is 5. So this time of 20 seconds must correspond to this velocity. And the slope would look like this. Then the motion is maintained and we have this within 60 seconds. Oh, let me draw well. Let's take it like that. Then the body decelerates uniformly to rest. This is how the graph must look like. This is how the graph must actually look like. Please, any question? So let's go to the question. You, Giovanni.
So please, how is V2 equal to V3?
Giovanni, I'm listening.
Please, how is V2
Oh,
equal
Giovanni,
to V3?
maybe it's a mistake. Class, can you hear me? Giovanni. Hello, class.
Sir.
Can you hear me?
Yes.
Yes.
Giovanni, your
Yes.
hand was up. Okay.
Yes, sir.
Using
So
the
I said, how was V2?
hurry up. I'm listening.
So how is V2 equal to V3?
You see, look at it. This is the first part of the motion. This is one, the first part. There's the second part, the third part of the motion, and then the fourth part of the motion. Here, the body's acceleration is 8, and then go to a final velocity of 240. The body reduced acceleration to 5, got to a final velocity of 340. 340 is the final velocity of the second part. So V2. Okay. But during the third part, because the motion, the velocity is maintained, the initial velocity during the third part, which is U3, is also equal to the final velocity during the same third part, V3. And they are all equal to 340. So over here, the velocity is 340. It is equal to the initial velocity during the third part, and it's also equal to the final velocity during the same third part. That is why I have U3 equal to V3, and it's also equal to U2. Giovanni, are you okay?
Yes, sir.
So during the fourth part of the motion, the initial velocity is also equal to the initial velocity during the fourth part is also equal to even V2. So this is also equal to U4 because it's maintained. Then it will decelerate uniformly to rest. So V3 V4 would be equal to 0. So that's the meaning of what I've done. Imelda.
So I don't understand why we went through all these processes and we didn't just draw the velocity time graph the way the question is giving it, but we went to look for the velocity is equal to U plus AT and all those things.
Imelda, you see, I must break the question into steps to you so that you would understand why I'm calculating V2, why I'm calculating V3 and all that. Is that okay? If you don't take it step by step, during the first, the motion is in 4 parts, where the acceleration is 8, where the acceleration is reduced to 5, where the speed is maintained, and where it decelerates uniformly. So I'm doing this for you to step by step follow what I'm doing. Are you okay? Emel, are you okay? If you don't do that, the tendency of you taking the acceleration as a deceleration, which I discussed earlier, is high. That's why I'm doing this. All right.
That's so. Why didn't we do this like this for the other ones?
You see, this is a complex question, okay, compared to the other ones we've solved. Class, do you agree with me?
Yes.
This is a bit detailed. In some of the first questions of just 3 steps in motion, we are good to go. But here we have 4 different aspects of the motion. So you must break each and every one down, use the equations of motion to get what is expected at every stage. That is why. All right. So using the graph, calculate I, the maximum speed attained during the motion. And obviously, you could see that the maximum speed attained during the motion is 340 meters per second. Amelda, are you okay? Giovanni, Benjamin, and the rest of you. Yamieni, mute yourself. Then I.
Sir, please, your line is breaking.
But can you hear me, class?
Yes.
So once you are hearing me, I think if the line is breaking and others can hear me, please then try and then rejoin. Maybe that would sort out the problem. So I calculate the average retardation as the body is being brought to rest. The average deceleration. So average retardation or deceleration is equal to, okay, the slope of the fourth part of the motion. And the slope is that change in the vertical. Don't forget retardation is acceleration but negative. So what is the change in the vertical? The vertical, what is the final velocity? The final velocity is 0 minus the initial velocity, 340, divided by the time interval, 130 minus 110, 20. So divide 34 by 20. What is 34 divided by 20? That is 17, right? Can you hear me, class?
Yes, yes.
So minus 17 meter per second squared is the average retardation or deceleration. Then the total distance traveled during the first 50 seconds. Total distance traveled during the first 50 seconds is this. So is the area between the graph and then the time axis. The area between the graph and the time axis. So class, calculate this for me. Start work and make me proud. Let me take attendance while doing this for me. The area under the graph and then the time axis. When I finish, I'll also discuss the same thing with you to see if you are doing the right thing. Yes, Kingsley, give us what you got. Kingsley,
Sir, please, I'm not done.
okay. Who is true? Gideon, go ahead and share it with us.
Yes.
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 Hello, Gideon.
I have a question. Sir, you want to ask something. Sir, you mean to find the distance travel within the first 60 seconds?
Yes.
Okay, sir, please. I'm saying how you solve it. How I got to answer.
Okay.
Okay. Sir, please. Sir, you find the distance traveled within the velocity of 240 meters per second, which you use the formula S is equal to ut plus half AC squared.
But we have to use the graph. Oh. Yes, I know you can use the equations of motion.
I need a tiny bit.
But you see, the question is using the graph. So we are using the graph to do this, Gideon.
Okay. So, but you also use my methodology for it.
The examiner will decide what to do with you because you are going contrary to the instruction. Okay.
Okay. Yeah.
And so do not give yourself up for that such decision. All right. So please, if you have a value, share with us what you got. All right. You see, this area is 2 in 1. You see the shaded area. I have a triangle. I also have a trapezium. So the area of the triangle, half times height, base, which is 30, times height, which is 240, 40. So we have 15 times 240. What is 15 times 240? I'm waiting for you. 15 times 240.
3,600.
1,600 meters.
So this is 3,600 meters for the first part. Then the second area is the trunk. Or say,
Sir, please, can you use the formula S is equal to UT plus half AT squared?
S is equal to U2. S is equal to what? Oh,
UT.
Frank, what I'm saying is that we can also use the equations of motion, but the question asks that we use the graph. Are you okay?
Yes.
So we are using the graph as required by the question. That's why we are doing this. And that's the same question Gideon asked. So the next area is area of a trapezium. So half A is 240 plus B. B is 340. And H is the height perpendicular to both, and that is 50 minus 30, which is 20. So we have 10 times 580, and that is 5,800. Therefore, the total distance traveled or covered during the whole during the first 50 seconds would be equal to 3,600 plus 5,800, and this is totaling. What's the total?
9,400 meters.
9,400 meters.
100.
So that's the total distance traveled during the first 50 seconds. Then the next question. Average during the same interval as in I. Jesse, mute yourself. So average speed. Okay, average speed, V average, is equal to total distance over total time taken during the same interval as in I. So this question refers to I. So this is actually I question. Sorry, I have not presented it so well, but so this is IV. So the average speed will be the total distance, which is 9,400 divided by the total distance, which is during the first 50 seconds. So we have 940 divided by 5. Please do that for me. 940 divided by 5.
188 meters per second.
188 meters per second. All right. So simple. So please, when acceleration is reduced, do not take it as a deceleration. If it's a deceleration, the question will state it. Okay, just as it was stated in the final part of this question, that the body maintains the speed attained for 60 seconds after which it is brought to rest in. So once it is being brought to rest, then it means the body is decelerating, coming to a stop. All right. So let's recap what we have done. Then I'll give you another beautiful question. Then we wrap up on linear motion. Let's look at the difference between distance and displacement again. Distance and displacement. Yes, class, what is distance? What is distance covered by a moving body? Yes, anybody? Distance. There are some few additions I want to add. Imelda, are you there? Giovanni, Gideon.
Yes, sir.
Anna, talk to me. Imelda, go ahead. What is distance? Oh, Frank.
Distance is the interval between 2 points on a straight line.
So with distance, we are only, yes, you are right. With distance, we are looking at the total amount traveled. Okay. Total amount traveled. So this time we are just looking at the distance from one point to another point, the total amount traveled. So that, then what is displacement? Gideon.
Displacement is distance in a specific direction.
Yes. So distance in a specific, Gerard.
So displacement is the distance moved in a straight line from the starting point to final position.
So, right, once you are talking about position, it means you are bringing direction. Maybe covered or travel. Gerard, your hand is still up. Then we are saying that displacement is distance in a specified direction, or displacement is defines the position of an object. So a body moved from one point, maybe from the north to the south. Its current position is the south. Its initial position was north. So once I'm indicating positions, it's displacement. So for class, for a moving body, can the distance traveled be zero? Have traveled be zero? Class, I've asked a question. For a moving body, can the distance traveled be zero?
No.
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 But can the displacement be zero?
Yes.
Yes.
You explain also. I'm taking the question again. For a moving body, can the distance traveled be zero? And what's your answer?
No.
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 For distance can't be zero. But can the displacement be zero?
Yes.
Who is saying yes?
Yes.
Giovanni
Yes.
or Gideon? Gideon, explain to us. Why do you think? Yes, I agree with you. Once the body is moving, distance travel cannot be zero. But why are you saying that displacement can be zero? Gideon.
Displacement will only be zero if the distance is not moving in a specific direction. Let's say it's moving in a zigzag motion, it's not moving in any specific direction, but it has covered a particular distance. You can say the displacement is zero.
I'm not so much convinced. Any more hands? Osafo?
Please, if the distance can be zero, I also think the displacement can be zero.
Okay, he is saying that the displacement cannot be zero once distance is not zero. Yes. Let me hear from Gerard.
Sir, please, displacement can be zero.
How?
Sir, please, when an object has moved a certain distance, as long as it ends up in the same position it started from. For example, if a person is walking around a circular track and returning to their starting point, they might have traveled a significant distance, but their overall displacement is zero because they are back where they began.
Gerard is actually hitting the nail on the head. So, example. So, for a moving body, yes, displacement can be zero. Distance cannot be zero, but displacement can be zero and even be negative. Benjamin?
Yes, sir.
Please.
For a moving body, the displacement can be zero. This can happen when the body returns to its initial position after moving.
Exactly. So, with displacement, we are always interested in a point of reference, the starting point. So, Emelda starts a journey from A. Then went to a point B. All right. Over here, she moved from A to B. So if you ask me to calculate the distance covered, it is just the amount of travel between A and B. If you ask me to calculate her displacement, it will also be the same as the distance. So where the direction of motion does not change, distance is equal to displacement. Distance is equal to displacement because here the direction of motion does not change. Giovanni, your hand is up.
Mistake, sir.
Direction of motion does not change. And so in this case, in this particular case, average speed would also be the same as average velocity. So if the direction of motion does not change, that is why we always take distance to be equal to displacement. Okay. So example, Emelda moved from A to B. The distance from A to B is, yes, Emelda, give me a value as distance from A to B.
5 to 15.
Oh, Emelda is gone.
So I'm here.
10. 10
She's gone.
it took Imelda 1 minute to cover this distance. So if I'm to calculate for her average speed, the average speed, which is the total distance traveled over the total time taken. So I have 10 meters divided by 60 seconds. And so this is equal to 1/6 meter per second. If I'm to calculate average velocity, it will be the same because the direction does not change. Average velocity would be equal to total displacement, which is 10 over total times 60. However, if I am creating a different scenario, Giovanni starts a journey from A, traveled 10 meters per second, or yes, went to B and returned. So this time, this is his initial movement. Then returned and returned. If you return, it means you are coming back to your starting point. If you ask me to calculate the total distance, the distance will be, if this is 10, this is 10, then the total distance of Giovanni is 20 meters. And the average speed will be equal to 20 over 20 seconds. Yes, 20 over 120 seconds. Meaning we'll have the average speed to be 1/6. Okay. Interestingly, the displacement is 0. The total displacement of Giovanni's movement is 0. This is because with displacement, we are interested in a reference point, a starting point. So he moved from here to here. Assuming this is due east, from A to B is due east. And this is taken as positive. And when he moved from B to A, due west is taken as negative. So when you add 10 plus -10, this is 0. And once the total displacement is 0, the average velocity would also be 0. Class, do you understand?
Yes, sir.
Can you please repeat yourself?
Class, do we understand?
No,
Oui.
please.
No, sir.
Hey. Hello. Hello, can you hear me?
Yes, sir. You can
I
hear.
hope you understand now.
Yes, please.
Sir, please, can you explain yourself again?
Yes.
Okay. Mary, what I'm saying is that, so Giovanni moved from A to B, covered 10, and then returned back to where he started. So if I'm to determine his total distance, it will be 10 plus 10. Here, I'm only interested in the magnitude of his movement. So total distance is 20. But if you ask me to calculate the total displacement, it will be 0. 10 minus 10, and that will be 0, because here you must consider direction. He moved from A to B positive, B to A negative. And so when you add, the total displacement is 0. So with displacement, we are always interested in a reference point. Emelda.
So does it become negative 10 because it's going backwards?
Exactly. You see, with displacement, we indicate the direction of movement. Are you okay? Now,
Yes, sir.
supposing Giovanni returned, in his return from B, he moved to a point C. He moved to a point C. What will be his total distance? And a point C is 5 meters from A. What will be his total distance and his total displacement? Yes. Amelda, what's the total distance?
Say the question again.
In Giovanni's return, he continued his motion to a point C when he was returning. And C is, at the point C is 5 meters from A. What will be his total distance and the total displacement? Anita, are you here?
Yes, please.
Anna, are you here?
Yes, please.
Total distance. Anita, what will be the total distance?
25 meters.
25 meters.
25. What will be the total displacement?
5 meters.
Negative 5.
It's negative 5.
Sorry.
Yes.
Okay. So because from A to B, positive 10, and then B to C, negative 15. So when you subtract, we are always subtracting it from the reference point. So you must subtract B to C from A to B. So that's the difference. So displacement for a moving body, this distance cannot be 0. But displacement can be 0 and even be negative. Understood?
Yes, sir.
Another question. Let me give you another question. A woman walks 300 meters due east in 100 seconds. A woman walks 300 meters due east in 100 seconds. Then 200 meters due west. Then 200 meters due west in 80 seconds. Calculate her average speed and her average velocity. A woman walks 300 meters due east in 100 seconds. Then 200 meters due west in 80 seconds. Calculate her average speed and her average velocity. Start with. Benjamin. Benjamin, or it's a mistake?
Sir.
Your hand is up. Or
Sir,
what?
the average speed is 100 meters per second.
Okay, so you just finish it. We'll discuss it, so you use that to mark whatever you've done. Benjamin again. So please, if you are done, put it down, okay? Just just write it. We'll discuss. Press like you here. Press slide one. Okay, so I'm sure we are all through. Let's discuss it. So the average speed is equal to total distance over total time. And the total distance is 300 meter due east plus 200 meter due west divided by the total time 100 plus 80. So we have 500 divided by 180. And what is 50 on 18 or 25 on 9?
Yes, 2.777777778.
Yo, Pate.
8.
So this is 2.7
or 8.
78 or 778 meter per second. Listen, it's always advisable to express it in 3 decimal place. That's why I'm writing 778. Okay. What about the average velocity? Average velocity. Yes. What's the total displacement? Class, what's the total displacement? Oh, anybody can contribute.
100 meters.
Okay, total time. Okay, so total displacement, 300 meter due east, 200 meter due west. So when you subtract, we have 100. Thank you. 100 meters divided by total time of 180. So this is 5 on 9, right? And what is 5 divided by 9? I'm listening.
1.6.
0 points.
1.6.
Is that 1? Is 0.556, isn't it?
Yes.
Please, any question? If you have any question, quickly ask before I give you a new problem. All right. Then, one last question. I'm going to take a shot and send it to the group to see how you can. All right, so please listen. Listen to the question. Jill walks at a distance. Jill walks at a distance, at a constant speed of. I take the question again. Jill walks at a constant speed to her friend's house. Jill walks at a constant speed to her friend's house, which is 120 meters away in 60 seconds. Away in 60 seconds. After talking to her friend for 30 seconds, Gideon. Gideon, listen. Jill walks at a constant speed to her friend's house 120 meters away in 60 seconds. To her friend's house 120 meters away in 60 seconds. After talking to her for 30 seconds, she returns home at a constant speed in 40 seconds. After talking to her friend for 30 seconds, she returns home at constant speed in 40 seconds. The question is that draw a distance time graph for this motion. That is I. Draw a distance time graph for this motion. And I. Draw a displacement time graph for this motion. So you are drawing a distance dash time graph for this motion. I draw a displacement time graph. They will not be the same because the directions are not the same. The gel is changing direction after a certain time. So sketch a displacement time graph. Then I sketch, a distance time graph, and I displacement time graph. And I'm giving you 10 minutes to think through this question. And then I'll get back to the house. Start with. Gideon, your hand is still up. Or the usual mistake. So use 10 minutes for your sketch. 10 minutes. You are sketching a distance time graph for the motion and then a displacement time graph for the same motion. I'll get back to you. Frank.
Please, the constant speed that she uses to go home, is there any value for it?
Oh, Frank, you can calculate for it. Once you have the distance, you have the time for each motion you can. Okay.
Okay.
Using the equation. Five minutes more. Five. Okay. I think our time is up. Time is up. So let's discuss. All right. So Jill works. Let me open to a new page. Jill walks at a constant speed to her friend's house, which is 120 meters away. Okay, so distance 120 at a time of t equals 60 seconds. Therefore, the distance time graph, okay, both distance time graph and acceleration, I'll need the slope. So the slope of a distance time graph must give me the speed. Okay, so the speed for distance time graph will be equal to the distance traveled over the time. So 120 over 60. And this is 2 meters per second. When Jill was moving to the friend's house, and when Jill was returning, once she stayed there, she wasn't in motion. So there will be zero speed. But when she was returning, the slope, which is the speed, would be equal to the same distance, 120 meters, divided by the time taken in making the return, 40 seconds. Maybe so this time around, it will be 3 meters per second. So she moved with her speed. I think she used less time here. Maybe when she was returning, she was hungry then. So she wanted to get home quickly. That's why she moved at a greater speed when she was returning than when she was going. Class, are you there?
Yes, sir.
So after spending that time, Jill was hungry. And so she was becoming angry. And so she had to. So let's plot the distance time graph. Just a sketch. So this is distance slash meter. The total distance was 240, 120 when she was going, and then another 120 when she was returning. So 240. This is 120. Okay. Then the total time 60 plus when she spoke with her friend 30 plus taking 40 seconds to return. So, 130. So, if we are even going 2020, so 20, 40, 60, 80, 100, 120, 140. So what's the, she accelerates by this margin and then went to her friend's house. So the slope, that is usually 60 seconds. This time of 60 seconds must link to a distance of this covered. Therefore, the graph will be, this is the graph. This is just to link those details. Then after talking to her friend for 30 seconds, so 60 plus 30, that's 90. 90 is half of this. They were talking. So the distance covered 0. Then she returned home. Okay. For another 40 seconds. So 130 is here. $130 is here. So this time must correspond to a distance of this. Pardon me. And the graph must be this. So this is the distance time graph for gel. Okay, where she starts from E, go to B, C, and finally D. How many of you got this graph correct? Let me see by hands. Okay, more hands, more hands. So I have, okay, 6 of you. All right. Then the displacement time graph. Amelda, is it for correct graph or question?
The correct graph.
Okay. Let's look at the displacement time graph. So another sketch time axis, then displacement axis. Over here, we are not interested in the total distance. It's not a question of total distance, but it's the position of the body to a reference point. So let's indicate 20, 40, 60, 80, 100, 120, 140. Half of this will certainly be 130. So this is time. Then displacement. He went through a displacement of 130, 120. Even if you indicate there can be a displacement of 240 though, as in this. And I'll explain later explain why. So the velocity during the first part is still changing displacement. He moved from her house to the friend's house 120 meters away. So the distance, okay, with regards to her starting point to a friend's house, the displacement is still 120 and took a time of 60 seconds to do that. So the speed is 2 meters per second. Okay, the speed is still 2 meters per second. So this 120 distance must go with 120 displacement must go with this time of 60. So this is actually the motion. Yes, the slope is equal to the speed. Still that. Then Jill, after talking to her for 30 seconds, they talked, no motion, yes. So no displacement for 30 seconds. So this must connect half of this. 60 plus 30, 90. Assuming this is it. And then from there, hold on. Then after talking to her friend for that number of minutes, she returned home, meaning Jill returned to her starting point. She started from this point. Let me use, oh shit, not right. She started from the origin here. So after talking to her friend for that long, she returned home. So the displacement 120, she will returning, reversing her path. So 120 will reduce to 0. This is the displacement time graph. So this question is similar to the first question we solved, where move from this point to this point, A to B, and then return from B to A. And when you find the displacement is 0. So she covered the distance 120, talked to her friend for 30 seconds. You see, so over here, the displacement is 0. Then she returned home. So at this point, total displacement is 0. Okay, this is the displacement time graph for this motion. How many of you got it? Frank got it. Who else? Isaac? Oh, okay. Great. And those of you who couldn't get it, I'm sure you are learning from your mistake, right? The beauty of everything is to understand whatever we are doing. All right. Gerard, your hand is up. Gerard. All right. So assignment. No, you are doing this right here. You think to. I'm taking a shot of it, and then we'll drop it on the platform. So please check the platform for the question, which you discuss for. Okay, so the question is done. It's on the platform. Let me read the question with you. This velocity time graph shows a body moving at constant velocity for 4 seconds and then decelerating uniformly for 6 seconds. Class, please, have you noticed the question? Class, do you have the question? Hey, are you there?
Yes, sir.
So
Yes, sir.
this graph, velocity time graph, shows a body moving at a constant velocity for 4 seconds and then decelerating uniformly for 6 seconds. Find I, the initial velocity, U, the final velocity, V, II, the acceleration during the first 6 seconds. The acceleration during the first 6 seconds, and IV, the displacement from its starting point. The displacement from its starting point, and V, the total distance traveled by the body. The displacement from its starting point and the total distance traveled by the body. Start with 10 minutes. I think 10 minutes is a lot. That would take us to 11:51, but we must discuss. So please, 6 minutes. 6 minutes for this work. It's 11:42. Giovanni, have you managed to enter the class? Giovanni.
Sir.
Okay. I saw your message. That's why I'm asking. Dara, thank you for uploading it here.
Sir, please.
Jadine.
Sir, please, when we're done, should we send it to you
So we'll discuss,
on the...
we will discuss it. So
Okay. Yes, sir.
Benjamin.
Thank you.
Welcome. Benjamin. Benjamin Inti. Oh, it's a mistake, as usual.
Say, done.
Okay, we'll discuss it. So if you finish, just keep it. And you mark yourselves. But please, you still have about 3 minutes. So look through it.
Yes, sir.
Benjamin, mute yourself. Okay. You have 2 minutes to go. 2 minutes. Okay. All right, so let's look at the question. Class, let's discuss it, okay? So the velocity time graph shows a body moving at constant velocity for 4 seconds and then decelerating uniformly for 6 seconds. Find I, the initial velocity. Yes, what's the initial velocity? Anita, what's the initial velocity? Anita, are you there? Class, anybody? Anybody to answer that? The initial velocity. Hello, can you hear me? Give me feedback. Class, can you hear me?
Yes, sir.
Talk to me. What's the initial velocity? Hey. No one is talking. Gideon, go ahead.
3 meters per second.
Jesse, what's your value? 2.
3 meters per second.
So the initial velocity is 3 meters per second. I. The final velocity. Frank. Frank.
Is 0 meter per second.
Okay, Frank is not talking. Let's have
Hello.
Zidel. Or Imelda. Imelda,
Is
go ahead. Time is not on our side.
per second. Negative 1.5 meter per second.
Imelda, I'm listening.
Say negative 1.5 meter per second.
Minus 1.5
meters.
meter per second. Thank you. Then the acceleration A during the last 6 seconds. The acceleration during the last 6 seconds. Yes. Gideon, what's your answer?
So I'm to answer.
So the acceleration is negative 0.75 meters per second.
That's Gideon's answer, negative 0.75. Jesse, what's your answer?
Say Benjamin.
Negative 0.25 meters per second.
Negative 0.25.
25.
Okay. And Benjamin?
So negative 0.75 meter per second square.
All right, let's see. There are 2 possibilities in calculating this. So if I use during the whole period, and I have the last 6 seconds, I have a graph which looks like this. I'm only looking at that part, okay? So this is to a time of 4, and this is, okay, it extends. This is a time of 10. Okay. So since it's a uniform deceleration, I can pick this point for the acceleration, right? So when you pick changing the vertical, so it's like picking this whole section. It's like picking this whole section and then this whole section. So the change in the vertical, delta V over delta T. And this is 3 minus 0 minus 3. Okay, I think I need to include what is here. This is also, oh, I should have drawn this very well. Okay, let me use, if I use that, I have changed in the vertical, which is negative 1.5 minus the initial velocity, which is this, divided by the time interval 10 minus 4, which is 6. So we have minus 4.5 on 6 plus what is 4.5 divided by 6?
0.75.
So minus 0.75 meter per second squared. Another way of solving the same thing is that I don't know this time. This time here, I don't know. Let that be T. So I want to this time use this graph and this graph for the same acceleration. And they must be the same. So if I use the bigger graph, this is 3. This is also 0. Then this is 4. So change in the vertical is equal to 0, 0 minus 3 divided by change in the horizontal, which is the unknown time minus 4. T minus 4. This, when I use the smaller triangle, I can also use this to find out the acceleration. Change in the vertical, which is negative 1.5 minus 0 over change in the horizontal, which is 10 minus T. Once it's that same straight line, the acceleration of this must be equal to the acceleration of this. So it means that minus 3 over T on 4 is equal to minus 1.5 divided by 10 minus T. The minus can cancel out. And when we cross multiply, we have 3 times 10 minus T is equal to 1.5 times T minus 4. When you divide through by 3, you have 10 minus T is equal to, what is 1.5 divided by 3? Are you there? Okay. So let's open the bracket at the right hand side. 0.5 T minus What is 0.5 times 4? Imelda, I'm listening.
2.
So let's group like terms. When you group like terms, negative t crossing the equal sign. So we have 1.5 t is equal to 12. Okay, the 2 would also cross to add up to 12. When you divide it by 1.5, you have t to be equal to, what's the value of t? 12 divided by 1.5.
8.
8. So it means that the time over here is actually 8 seconds. If t is 8 seconds, then when I use any of the two accelerations, a is equal to minus 3 over 8 minus 4 is 4. What is 3 divided by 4? What is 3 divided by 4? Hey, you people are delaying, you know.
0.75.
So the value is the same. Okay. Now the displacement from its starting point is that, you see, this motion is along the positive y-axis. This small motion is along the negative y-axis. Change in direction. So determine the area here, and subtract the negative one from the positive one. And that will be the total displacement. So let's finish quickly. What's the base? The base is 8 minus, this is 4, times the height. Hey, I've left out the other part. In fact, there are some parts. It's like this. So this area, the total area here, this is half times 3. This is giving us 6. Because into 2. Then this is plus the rectangle. Okay, 3 times 4. That is 12. So this is giving us 18. The whole of this area is equal to 18. Then this small area, this is also half times 2 times 1.5. So it's 1.5. So when you subtract 1.5 from 18, okay, you have 16.5. This is the total displacement from the starting point. So it is 16.5 meters towards the positive side of it. Then the total distance traveled will be the whole of this area plus this small area, which is 18 plus 1.5, 19.5 meters. But I'm done with you. Any question? No question. It's 12 o'clock exactly. This is where we end today's show. Frank, you are asking a question when it's beyond 12. Okay, go ahead. Frank, go ahead.
Oh, it was a mistake.
Okay. All right. So the video will be uploaded and I'll forward your work set to the group. Until Thursday, take care and revise. Bye-bye. The newcomers, I'm still waiting for your assignment pages. Do not forget to create it and pass your assignments through it. Go to the platform, the YouTube, subscribe, share, and then comment. Until then, bye-bye.
Bye.
Bye. Goodbye.